Hi YouTube, Tim Eckert here. In this video, we're going to go through some questions on some arithmetic sequences and some questions on simplifying roots and rational exponents. This is a quiz review for my Algebra 1 honors. Okay, let's take a look at number 1. It says, write the recursive formula and find the next term in the sequence. First thing we can do is find the next term in the sequence because we're adding by 4 each time here. So if we add 4 again, we're going to get just 11 plus 4, which is 15. So that's the second part of the question. The first part is to write a recursive formula. So we're going to say the nth term, the term we're looking for, is equal to the, and you can read this as a sub n equals a sub n minus 1. A sub n minus 1 stands for the term before it. And then to take the term before it and get to the next term, we have to add 4. So we're going to put plus 4. So that's the recursive formula. A lot of times you'll see a sub 1, or even sometimes a sub naught. Let me write a sub 1 a little bit better. Equal to what the first term equals, so you can use this formula. Because if you don't have that, and you don't know what one of the terms in the sequence is, it's tough to find the next one. Okay, let's take a look at the next problem. Problem 2, write the recursive formula and find the next term in this sequence. So we have negative 5, negative 15, negative 25. Now, why this negative number is getting larger, you're actually subtracting 10 to get to the next number in the sequence. So to go from here to here, you subtract 10. To go from here to here, you will also subtract 10. And if we take away 10 from negative 25, the next term in the sequence is going to be negative 35. So that's part of our answer. We also want the recursive formula. So I'm going to say a sub n equals a sub n minus 1, and we're taking off 10, so we're going to have minus 10 here. Also, if I'm being helpful, I'll indicate the first term. I'll say a sub 1 equals negative 5. Okay, so that's the first part, the recursive formula. Okay, let's keep going. All right, we have another sequence here. We're going to find the 12,331st term in the following sequence. So we go from 3 to 8, we add 5. And then from 8 to 13, we also add 5. So this is an arithmetic sequence. So the notation I'm going to write here is a sub 12, 331. That's going to equal the first term, 3, plus, to get the 12,331st term, we're going to do 1 less than that times 5, because we're going to increment by 5 1 less than that. So I have 12,331 minus 1 times 5. So that's going to equal 3 plus 12,330 times 5. So I'm going to get my calculator and do this one out. So we've got 3 plus 12,330 times 5, and that gives me, for a solution, 61,653. So we can say our 12,331st term equals 61,653. Okay, let's keep going. Okay, problem 4, find the 908th term in the following sequence. So we go from negative 3 to 0, that's adding by 3. We go from 0 to 3, that's adding by 3 again, so this is an arithmetic sequence. We add by a constant amount, or sometimes you have these sequences where you take off by a constant amount. So we're going to say a sub 908, so the 908th term, equals negative 3, the first term, plus we're going to add 3 907 times, so 1 less than 908. So 908 minus 1 times the amount we're adding, 3. So it's going to be negative 3 plus 907. Whoops, that's not a great 0. 907 times 3. All right, so if I do that out on my calculator, negative 3 plus 907 times 3, I get 2,718. And that's the 908th term. Okay, let's keep going. Problem 5, we're taking the cube root of 125 x to the 6th y cubed z to the 9th. So the cube root of 125 is just 5. The cube root of x to the 6th power, if we divide 6 by 3, we get x squared. Because remember, this is like the 1/3 power, so 6 times 1/3 is 2. The cube root of y cubed is just y. And the cube root of z to the 9th is z cubed. And that's my solution there. Another way you could think about this is the cube root of z to the 9th is z cubed because z cubed times z cubed times z cubed, well, that equals z to the 3 plus 3 plus 3, z to the 9th. All right. So you can think about the exponents for the variables that way as well. All right, let's keep going. This next one we have, we're taking the negative 1/5, or we're raising this whole quantity to the negative 1/5 power. So what that means is we can write this as 1 over this whole thing to the positive 1/5 power. So we're going to write negative 243 x to the 5th, y to the 10th, to the 1/5 power. Fix that. To the 1/5 power there. All right, so that's going to be 1 over the 5th root of negative 243 is negative 3. The 5th root of x to the 5th is just x. And the 5th root of y to the 10th is y squared. And typically we'll write the negative out front. Positive divided by a negative is a negative, so we have negative 1 over 3x y squared as our solution for number 6. Okay, let's go to number 7. We have negative 121 to the negative 3/2 power. So that's like 1 over negative 121 to the positive 3/2 power, which we can break apart into 1 over negative 121 to the 1/2 power, and then cube that. Now, negative 121 to the 1/2 power, that's the square root of negative 121. Well, that's undefined because that's not a real number. So on your calculator, it would be undefined. Because you can't multiply a negative by a negative and get a negative, and you can't multiply a positive by a positive and get a negative. So this problem, this solution, or what you can write, is undefined or no real solution here. Okay, last problem. We got negative 64 x squared y cubed to the 1/3 power. So first we'll take the cube root of negative 64, which is just negative 4. Because if we multiply 3 negative 4's together, we'll get negative 64. I'm going to ignore the x squared here for a moment. The cube root of y cubed is just y. And then we're going to keep this x squared under the cube root because we can't really simplify it any further. So this is going to be the cube root of x squared. Let me fix my x there a little bit. So the cube root of x squared. So our solution is negative 4y times the cube root of x squared. Hopefully this video was helpful to you. If it was, please like and subscribe.